Hello everyone. In the last lecture we have discussed about some terms related to butt weld, that is reinforcement, effective throat thickness, size of weld, length of weld and effective area of weld, and after that we have discussed about design strength of butt weld. Okay. So in this lecture we will solve an analytical problem related to butt welded joint. So analytical problem means we have to calculate the strength of the joint, that means we have to calculate the load carrying capacity of the joint. So here the question says two steel plates of 16 mm and 12 mm thick are to be joined by butt welding. If effective length of weld is 180 mm, then determine the strength of joint for single V butt weld joint, then for double V butt weld joint. Okay. So here two cases are given. Okay. So the first case is single V butt weld and second one is double V butt weld. Okay. So for these two cases we have to calculate the strength of joint. Okay. So here you can see from the question it is clear that this is the butt welded joint and two steel plates are given of thickness 16 mm and 12 mm. Okay. So let us first calculate the design strength of joint for the first case, that is single V butt weld. Okay. So here you can see that this is the single V butt weld case, as here the edge of these two plates are look like V shape at the top. Okay. And here the weld is provided only on one side. Okay. So this is called as single V butt weld. So here the thickness of this plate is 16 mm, that is given in the question, and here the thickness of this plate is 12 mm. Okay. And the length of weld is given in the question, that is 180 mm. Okay. So length of weld is 180 mm. So let us first calculate the strength of joint for single V butt weld. Okay. So design strength of single V butt welded joint can be calculated by the formula, that is yield stress divided by gamma mw into area of weld. Okay. So here you can see it is asked to calculate the strength of joint, and in the last class I have already discussed that in case of welded connection, to get the value of strength of joint we need to calculate the strength of weld. Okay. Here there is no rupture failure of the plate, as there are no holes at the joint, so there is no need to calculate the rupture strength of the plate. Okay. So here the strength of joint means strength of weld. Okay. So here we will calculate the strength of weld only. Okay. So you know that the yield stress for the material or yield stress for the weld is 250 MPa. Okay. 250 Newton per mm square. Then next come to gamma mw. Okay. So gamma mw is the partial factor of safety for weld. Okay. And that value you can get from the table number 5. But there are two conditions. Okay, for gamma MW, force of fabrication, the value is 1.25, and for field fabrication the value is 1.5. Okay, so if the welded connection is done in workshop, then you take the value of gamma MW as 1.25, and if the welded connection is done in field, then take the value of gamma MW as 1.5. As in workshop, the connection is done very properly, so the partial factor of safety, the value is less than that of the field condition. As in case of field, the condition can't be done properly. Okay, that's why for soap fabrication the factor of safety value is less. Okay, and here you can see in this question this condition is not given, whether the connection is done in workshop or field. This condition is not given. Okay, so if in the question these things will not be given, then assume that the connection is made in the workshop and take the value of gamma MW as 1.25. Okay, so as here in the question nothing is mentioned about whether the connection is done in workshop or field, so just assume that the connection is made in case of in workshop. So take the value of gamma MW as 1.25. Okay, then next come to area of effective area of weld. Okay, so in the last class I have discussed that effective area of weld is the size of weld into length of weld. Okay, and for both weld this size of weld is equal to effective throat thickness. So in place of size of weld we can write effective throat thickness. Okay, so this is the case of single V both weld, that means this is incomplete penetration. This is the case of incomplete penetration, as here the weld is provided only on one side. So this is the case of incomplete penetration, and for incomplete penetration effective throat thickness is equal to 5/8 into minimum thickness. Okay, thickness of thinner member. So here for this case, for this incomplete penetration, the effective throat thickness will be 5/8 into thickness of thinner member. Okay, so here you can see 12 mm is the minimum thickness. Okay, so 5/8 into 12. Okay, so here put the values, that effective throat thickness is 5/8 into 12 into length of weld, that is given in the question, that is 180. Okay, so this is area of weld. Okay, so put all the values here. So Fy is 250 Newton per mm square, that is a megapascal. Then gamma MW, that value is 1.25. Then into area of weld. So here area of weld is 5/8 into 12 into 180. Okay, so this value is coming 270. So this value will come in Newton, as here this 250 is in Newton per mm square, and here all the values, that is the thickness and the length of weld is also in mm. So this value will come in Newton. So you can write this value in kilonewton. that is 270 kilonewton. Okay, so we have calculated the strength of strength for the single V butt weld joint, that is 270 kilonewton. Okay. So next, calculate the strength for double V butt weld joint. Okay. So next, calculate the strength of joint for double V butt weld joint. Okay. So here you can see this is the double V butt joint, as here the weld is provided on both sides and the edge of these two plates, these two members looks like V shape on both sides, at the top and the bottom also. Okay. So the design strength of weld can be calculated by the formula, that is the same formula, that is Fi by gamma mw into area of weld. Okay. So here also yield stress is 250 Newton per mm square, gamma mw is 1.25. Then next come to area, effective area of weld, that is effective throat thickness into length of weld. Okay. So this is the case of double V butt weld joint, that means this is the case of complete penetration, as here the weld is provided on both sides. Okay. So for complete penetration, the value of effective throat thickness is equal to the thickness of thinner member. Okay. So for this case, the effective throat thickness will be thickness of thinner member. Okay. So here the minimum thickness is 12 mm. Okay. So put the values here. 12 into length of weld, that value is given in the question, that is 180 mm. Okay. So here Fi is 250, gamma mw is 1.25 into area of weld, that is 12 into 180. Okay. And this value is coming around 432,000 Newton. Okay. So this value also will come in Newton, as here the yield stress is in Newton per mm square and the thickness and the length of weld is also in mm. Okay. So then write this value in kilonewton, that is 432 kilonewton. Okay. So the numerical is very simple and math fetching. Okay. So this much all about today's class. In the next lecture, we will discuss about some codal provisions related to fillet welded joint. Okay. Thank you.